Hello everyone, it's November 22nd, Saturday, and you're tuning in with your host, San Note. Today, I'm super excited to pull a really cool trending article for eArchive for us to talk about. It's a bit of a brainy one, but trust me, it's totally fascinating. The title is, Unbiased, Cross-Modal Representation Learning for Food Image-to-Recipe Retrieval. And the curl is house://argslif.org/abs/2511.15200. Bro, that's a mouthful, right? So, let's break it down. Have you ever seen a picture of, like, the most delicious looking cake on social media, and you think, I have to make this right now? You try to use an app to find the recipe from the picture, but it gives you something totally wrong. It suggests a plain vanilla cake when you can clearly see strawberries in the picture. So frustrating. Well, that's exactly the problem this paper is trying to solve. The relationship between a recipe and a photo of the finished dish is, that's an effect. The recipe is the cause and the yummy-looking dish is the effect. But current AI models sometimes get this wrong. They just try to match the text of the recipe with the visuals of the image. The problem is, a single photo can't capture every single detail of a recipe. Imagine a recipe for drunken chicken. Chicken is obviously the star of the show and easy to see in the photo. What about the minor ingredients, like a little bit of ginger or some goji berries? They might be hidden, or maybe they dissolve during cooking. So the AI gets biased and tends to focus only on the big, dominant ingredients it can see. This means it can't tell the difference between really similar-looking dishes, like drunken chicken, steamed ginger chicken, or herbal chicken. They all look like little chicken. So what's the super smart solution from this paper? The researchers used something called causal theory. It sounds complicated, but the idea is actually pretty simple and clever. They identified that the ingredients are a major source of this confusion, or are what they call an infunder. So they created a way to fix this bias. Basically, they built a special plug-and-play module that you can add to existing AI models. This module is essentially a super smart ingredient classifier. When you give it a food photo, it tries to predict all the ingredients that should be in the dish. Even the ones that are hidden are not obvious. It's like giving the AI a little hint saying, hey, I know this looks like chicken, but I'm also detecting hints of ginger and goji berries. So you should probably look for a recipe that includes those. This process is called debiasing. It adjusts the AI's understanding of an image, making it focus on the complete set of ingredients rather than just the most visible ones. This helps the AI make a much more accurate guess and find the correct recipe. It's so cool. Now let's think about how this could be used in our daily lives. I can give at least 3 awesome applications. First, for health and nutrition apps. Imagine you're trying to eat healthy. You're at a restaurant or a friend's party, and you see a dish you want to try. You can just snap a quick picture with your phone. An app with this technology could instantly pull up the exact recipe, and then, automatically calculate the calories, fat, protein, and all that stuff. This would make tracking your diet so much easier and more accurate. Second, this would be a total game changer for interactive learning and cooking guides, especially with rare R. Picture this. You're wearing our glasses in your kitchen. You see a photo of a cool dish online, and just by looking at it, the recipe and cooking instructions pop up as holograms right on your countertop. The system could guide you step by step, maybe even highlighting the ingredients you need from your fridge. It would be like having a futuristic cooking assistant. And third, for smarter content discovery on platforms like Pinterest, Instagram, or food blogs. Right now, if you search for a food picture, you usually just get more pictures that look similar. But with this tech, the system could understand the actual ingredients and flavors. So, if you search for a picture of a spicy Thai salad, It could recommend other recipes that have a similar spicy and sour flavor profile. Even if they are completely different dishes, it's like searching by taste, not just by looks, which is amazing for discovering new foods to try. So, how does this compare to older technologies? Well, previous methods mostly just tried to directly match words from the recipe, like chicken, onion, and garlic, to the visual features in the image. Even with powerful models like transformers, they still struggled with that bias problem I mentioned. Other approaches tried to, like, disentangle features, separating the style of the dish from its core components, which helped a bit. But this Paper's causal approach, it's the first to treat the problem from a PRINT perspective for recipe retrieval. It tries to understand the underlying reason, the ingredients that produce the final dish. This makes the whole system more robust and, smarter. And the results are just incredible. They tested this on a huge dataset called RichUni. By adding their debiasing module to existing top-performing models, they consistently boosted their performance. They even set new state-of-the-art records. They also did a simulation to see what would happen if their ingredient classifier was perfect. The result? A near-perfect retrieval performance, with the median rank of the correct recipe being 1, meaning it was the top result more than 50% of the time. That just shows how powerful this idea is. So in conclusion, this paper introduces a really clever way to help AI understand the link between a food photo and its recipe by focusing on the ingredients as the causal link. This little fix makes a huge difference, leading to much more accurate recipe retrieval. That's all the time we have for today. I hope you found that as interesting as I did. This has been your host, Zain Noani, signing off. Catch you next time. Bye-bye.